Welcome to the College of Education.
What we did the other day, Mr. Morris and I were just seeing, we actually did quite a bit the other day. And it's supposed to be fast and furious because it is a boot camp. Most of it is going to be review, we hope, from what you have done in the past. And we will continue with that today. All right, how many of you love working with fractions? One person. So most people hate fractions. I don't know why we hate fractions, but that's okay. Maybe what we can try to do is make you not hate the fractions quite so much. That's what I say on my math classes. Since people tend to hate math, but as we know, math is very important. We can't live without it. So when I say the word fraction, what does it mean to you? Yes. Exactly. It's just a part of something. A fraction is a part. Now, what we say is fractions. For example, if I write a fraction up here, that's what you think about, 3/4, 9/16, whatever. But actually, we have three kinds of parts of something. The three kinds of parts of something that we normally use, we can talk about other kinds, but not on the GK, are common fractions. Common fractions are what we generally think of as fractions. Decimal fractions, what is the word that we generally use for decimal fractions? We just say decimal. Yeah, for example, if I have 27.3, we generally just say that's a decimal. But actually, it's a decimal fraction. It's a whole number and a fraction because, like she said, it's a part of something. And then if you make an 89 on your test in Mr. Morris's class, that's basically a percent. It means 89 out of 100. But like she said, it's a part out of a whole. So we have different kinds of fractions. But when we're dealing with our GPA review, it's generally going to be common fractions that we think of as fractions. So that's what we're going to look at. Reviewing how to do our operations with fractions today. And if you know this, fine, you can help us out. So we can proceed. No, we already went. Go ahead, is it
Yeah, I thought so too.
So everybody just smile for the camera. That's what we did before. Oh no. Right, just a little, Mr. Boyce. Yes, okay. So operations with fractions. How are we going to deal with adding, subtraction, multiplication, and division? And what's the other operation that we had? Exponentiation of the fractions. Okay? So adding fractions, you can't add 1/2 and 1/3. That is not the way they're stated there. So if you remember, out here, what do I get when I add 3 apples and 2 apples? 5 apples. What do you get when you add 3 oranges and 6 oranges? 9 oranges. What do you get when you add 2 apples and 3 oranges? Exactly. You can't add them together. You've got to call them something else. You might call them pieces of fruit. And that's what we have to do with fractions. Once they match, I can add apples and apples. I can add oranges and oranges. I can add pieces of the fruit. but we're gonna have to call it the same thing. Those are not the same thing. 1/2 plus 1/3. How are we going to handle it? I don't know if it's on the next slide or not. All right, so we're going to call them sixths. Why are we going to call them sixths? You all know this. Tell me why we want to call these sixths instead of halves and thirds. It's a common denominator. So you're all familiar with that term. So if I can add 6 and 6 because that's like adding up and out. So the thing is, how are we going to get these missing numerators so that we can add the 6 plus the 6? Does it show us? All right, so that is a graph that shows us how it fits in together, the 1/6. How many 1/6 are in the 1/3, and how many 1/6 are in the 1/2? Now, when you're computing on the GK, this is what you're going to do. Why did you call it 6? Why do you think we called it 6 up there? You say common denominator, but what is a common denominator? It is the smallest number that they will both divide into. Yes, very good. The smallest number that they will both divide into is 6. So now how do we find these missing numerators? All right, so some people do this. Let me bring this out here. What do I have to multiply 2 by to get 6? 3. So if I multiply by 3 over 3, what is 3 over 3? So you're telling me, what do you get if you multiply anything times 1? Same thing. So if I multiply 1/2 times 3 over 3, I really haven't done anything. It's multiplying by 1. We're going to change the form. We're going to change the form, but not that. Change the form, but not the value. That's a way for students to think about it. So 1 times 3 is 3. 2 times 3 is 6, and we already have that. We can do the same thing with the 1/3 times 2 over 2. 3 times 2 is 6. So here we get the 2. Now, most of us are familiar with that. Then we can get our final answer as 5/6, which will not simplify. We can talk about simplification later. Now, we did that sort of fast with adding fractions with different denominators. You have to find that least common multiple or common denominator, right? Same thing. Subtraction is the same. When you're subtracting, if I wanted to subtract those, 1/2 minus 1/3, it would be, what do you get when I subtract 2 apples from 3 apples? 1 apple. So here I get 1/6. So in order to add or subtract, it must match. You cannot add or subtract anything unless they match. Multiplication and division, that's a whole nother thing. We can multiply things all day, anytime, anywhere, anyhow. But adding and subtracting, they have to match. All right? He's throwing some negative numbers out there for us. But let's see. Maybe we can get some student participation this morning.
Yeah. Well, this is again a review. Where's the roll sheet? I mean, the attendance sheet. There we go. All right.
C is gonna be harder, but that's okay.
All right. Ms. Johnson, let's start with you.
The A,
Now, for the A, what's the answer for this, for A?
correct.
Correct. Ms.
No big
Smith,
deal there.
B.
I'm still on through.
Yep.
Are we sure about that? One over two. 3 goes into 3 one time, 3 goes into 6 2 times. Well, we could have said 6 goes into 6 one time, and 6 goes into 12 2 times. It doesn't matter how you get it, as long as you get it. That's what Mr. Moy said the other day.
Exactly right. For the GK. Ms. Brianna.
Now,
For number
this one is harder, but it's okay, we can handle it. What kind of numbers, positive or negative numbers, do we have here? Negative 5 1/4 minus negative 2 3/4. That's a negative number, and that's a negative number. Whose problem is this? Okay. So if this is the case, I can't really do those, can I? The way it's set up, actually, we can. You're right. You could do that if you wanted to change it back. Now, this is the way she said she wanted to do it. Can we go ahead and handle the minus the negative as a plus a positive? We can handle that. We did that the other day. Now, she says this is the way she wants to do it. All right, continue. This is not the only way to do it. This is a way to do it. One's positive and one's negative. So I've got negative 21/4 plus positive 11/4, which is going to be, combine them together. We want to help. We don't add the denominators. We add 4s and 4s, we get 4s. Negative 10 over 4, which is going to simplify. That is a fraction greater than 1. We can't say the I word because Dr. Fitzbanister doesn't like it. But so this is going to be 4 goes into 10 2 times, with how many left over? 4 goes into 10 2 times, that's 8. So we got 2 more left over. So 2 2/4. It is negative. Are we finished? No, we're not, because 2/4 will simplify. So our final answer there is negative 2.5. That is a way to do the problem. Anyone have a different way to do the problem? All right, then I'll show you a different way. Now, notice these already match. We've got 4s and 4s. That makes it easy. So we've got negative 5 1/4 minus the negative is the positive. So we have 2 3/4. Now, if we find the difference, finding the difference means what are we going to do? Take the difference between them. Difference means to subtract. So in this case, I can't really subtract 3/4 from 1/4. I can't do that because 3 in our number system, you can't take 3 from 1 unless we go negative, and that's going to mix this up. So if I call this, what if I remember when you borrow, if I want to subtract, let's see, 23 minus 17. You remember in the second grade when you rename or borrow, I can't take 7 from 3, so I'm going to take 10 away from the 2 and make it a 1 and make that a 13. You remember when we did that? That's what we're going to do in this case. So I want to borrow 1 from the 5 or rename, make that a 4. But what is, in terms of fours, what is the whole number 1? How many fours? 4 fours. So now I've got 4 fourths plus the 1/4. So now I can call that -4 and 5 fourths, which is the same thing. And the 2 and 3 fourths, I don't have to change it. But what do I get? -2 and 4 fourths and 2 fourths again. Same. So if you like the borrowing way, fine, just set it up and down. If you like to change it to a fraction greater than 1 way, the way she did it, that's fine too. Which way should you do it on the GK? Whichever way you will understand this.
The way that gives you the best answer.
Right. Now, they are the ones that are going to have all kinds of ABCs, D's, to try to get you mixed up. For example, they'll probably have a -7 and 2 fourths or something like that on there to try to get you mixed up. But you're not going to get mixed up. Right. So those are a little harder. All right, multiplications.
Well, no, we
basically already did that. We like, okay, prime factor. We didn't do the multiplications.
No, she didn't.
All right, we did the multiplication really fast. Multiplication and division of fractions is the easiest thing in the world. It's easier than adding and subtracting. Because for multiplication of fractions, we know that it's just going to be, you're going to multiply the numerators and multiply the denominators. And that's it. Simplify it if you can. So we know that if I want to multiply 3/4 times 5/6, it's just going to be 3 times 5 is 15, 4 times 6 is 24, and I'm finished, right? No, we're not finished. Why? That's going to simplify. So what number goes into 15 and 24 at the same time?
3.
Okay, so we can do that. 3 goes into 15 5 times, 3 goes into 24 8 times, and there's our answer. Remember, when you're multiplying two positive numbers together, what do you get? Positive, you multiply positive and negative, negative, negative and positive, negative, negative and negative. positive. When you're multiplying or dividing. And again, we did that the other day. What happens when? Now, let's go back to what Brianna had said before. What if I have a complication? I want to multiply negative 2 3/4 times 3 5/6. What did we say for multiplication? Not cross multiply. Cross multiply is something else. And that's one of my big things when I'm doing that. It's not cross multiply. It's multiplying across. Cross multiplying is when we have proportions. So multiplying, I can't multiply those across. Because if I multiply 2 times 3 and get 6, that's one thing. 3/4 times 5/6 is 5/8, that's another thing. And it will be wrong. It will be wrong. So what did we do when we did the change them to fractions that are greater than 1? I can't say the I word, Dr. Fitzbannister gets upset. So that one, you've already told me how to do it. 4 times 2 is 8, plus 3 is 11. So now we have a numerator and denominator. Over here, somebody do it for me. 18 plus 5 is 23 over 6. So now we can multiply 11 times 23 is, I have no idea what 23 times 11 is. 230 something. Someone punch that out. 253. 4 times 6 is 24. It's going negative times positive is negative. Don't forget that, because they will try to get you mixed up on the GK. Don't forget that. And then we can just take your calculator. Now, your calculator works in decimal fractions, right? So I'm almost glad we did this. So what you're going to have to do is, what is 250? How many times will 24 go into 253? 10 times. Now you got a decimal fraction. How many is left over for the rest of our fraction? And how are you going to do that? It's okay, we can handle it. So now let's figure out what is 24 times 10? 240. What's 253 minus the 240, 24 that we've already used? 13.
7 on it. You got it. Good job.
Excellent. Now for division of fractions, since the boot camp goes into a new section here. Division of fractions, I think we pretty well know. How do we divide fractions? Invert the second fraction. We have time, we can do some of these. But invert the second fraction and multiply. Remember, you got to change them to these first. You got to change them to the numerator denominator fractions first. If this was the division, we would simply call this negative 11/4 divided by 23/6. It's going to be negative 11/4 times 6 over 23. Invert the second number. Versus not to reason why. Just invert and multiply. You ever heard that before? Yeah. With your teachers. Prime factorization is a good topic. We love this. What is a prime number? A prime number is, it only has two factors. A prime number only has two factors. Itself and one. What numbers, for example, go into seven? Seven goes into seven. And one goes into seven. That's it. Those are the only integral factors, at least. The only ones that are integers that will go into the number seven. So it's a prime number. So if a number has only two factors, itself and one, it's a prime number. Now, sometimes, I doubt if this will be on the GK, this is just free information. How many numbers, how many factors does one have? So is one a prime number? No, one is not considered to be a prime number because one has only one factor. One. A prime number has to have two factors, itself and one. Right, good. So now, composite number nine. How many factors does nine have? Well, let's see. 1 and 9 always, and 3. So 9 would be a composite number. It has more than two factors. Every composite number can be expressed as a product of prime numbers in one and only one way. So you don't have to remember that, but just factor trees. Okay, factor trees will be on the GK. So we want to find the prime factorization, get all of the primes of 700. Well, there are many different ways to do this. And you just keep, you've done this before, just keep going down and down and down the factor tree. Anybody done a factor tree and can help me out here? Don't. She wants to call it 7 times 100. Now, I could call it something else. I could call it 28 times 25 if I wanted to. But this is what she wants to call it, and that's fine. All right, let's look at the 7. She is correct, by the way. Let's look at the 7. 7 is prime. We can't go any farther. So that one's there. She's saying she wants to split up the 100 into 10 times 10. That's what I heard, correct? Right? So is 10 a prime number? No, so let's keep going. She says 10 is 2 times 5. And this 10 is 2 times 5. Now let's look to see, is 2 a prime number? Yes, 2 is your only even prime, by the way. There's only one even prime number, 2. Is 5 a prime number? 2 and 5? Okay, so we've gone down the entire tree and we have prime numbers. So, is your GK going to look like this? No, it's not. It's going to expect you to write it out. And normally what you would do is take the smallest of these bottom numbers. What is the smallest between 7? See, there's the end of a branch, if you want to call it that. Can't go any further there. The smallest of these numbers at the end of the branches is 2. How many 2's do we have? 2 of them. So it's going to be 2 squared plus What's the next smallest number? 5. And how many 5s do we have? 2 times 7. We have only got 1 7. 7 to the first power. Okay, that's what she started with. And keep going down. Notice they did it differently, but it's the same thing. We get the same thing. Okay, good.
Why did you say 2 plus?
Oh, because I goofed up. It's always good when a student can find a mistake the teacher has made. In my classes, sometimes I give extra points to them.
I don't know about mine.
That'd be in my class.
I don't know about mine. Although I made very, very few mistakes.
So, greatest common divisor. Now, this is where we're taking 2 numbers. We're going to take 2 numbers and find what is the largest number that will go into both of them. All right, greatest common divisor is a little more complicated, but we can handle it.
Doesn't give an example, but
Greatest common divisor in 5 and 26. Well, let's see. It says do a factor tree. Well, 5 is already prime, so we don't have to worry about that one. So let's see. 26 is 2 times 13. So between 5 and 2 and 13, nothing matches. There are no matches there. The greatest common divisor between these is, anybody know? It would be 1. They're considered to be relatively prime. You can't do anything to those. Actually, I don't know if I've ever seen that on the GK. We'll have to do greatest common divisors, yes. But relative prime, I don't know about. Anybody seen that on the GK? This is a good one. So now, if we want to find the greatest common divisor between these 2, now this is a harder problem. But we can do it. Remember, you have calculators, so take out your telephones, take out your calculators. And do I have a brave person? Mr. Moyes?
next question I have is Ms. Saylor. Yeah.
Okay, so 216, we can do 4 and 54.
She's already working on it. That's a long factor tree, but that's okay. Let's see, what's the smallest number we have? It's going to be 2. How many 2s do we have at the bottom of the branches? 3 of them, so 2 to the 3rd power times, I won't make that mistake again. How many 3s do we have? 3 of them at the bottom of the branches. Times, did we leave anything out? So that's it. That's our prime factorization for 216. 234?
Let me get somebody else. Yeah, let's go with Ms. Gomez.
We're doing this fast, but that's,
Right. I guess it's gonna be 6
what? 6 and 39, I don't know, is that right? 39 times 6. Yes, okay, good. Did you come up with that yourself? Good numbers. Are we finished? Correct, we are not. 2 and 3. Is 39 a prime number? No, it is not. You have to be careful. Just keep punching those calculator buttons. 39 is not prime. It's 3 times 13. So prime factorization, only 1, 2.
2,
3 squared, and 1 13.
I was gonna say something about
Usually, doesn't matter if we, I mean, if you're doing the prime factorization, does it really matter the order? But by convention, we just start with a smaller number first. It makes it sort of easier to understand. Now, we got to get the greatest common multiple of these. We want the largest number that will go into both of them. And this is harder. So we want the largest number that we can get out. Now, here I've got 3 powers of 2. What is the greatest power of 2 that I have here? Only 1 power of 2. So I can't use the 3 powers of 2. The greatest one that I can get from both of these is the 1 power of 2. Right? 3 powers of 3, 2 powers of 3. What's the greatest number that I can extract from these 2? So it's going to be 2 powers of 3. 13. No 13. Can't do anything with the 13. So the greatest powers that you can extract from them is going to give you your greatest common divisor. So 2 times 3 is 18. So check out on your calculators. If she and I got it right, I'll claim part of the credit. Will 18 go into 216 all number of times on your calculators? How many times will 18 go into 216? 12 times. Will 18 go into 234? 13 times. So, good. 18 would be our greatest common divisor. Yes.
So for these specific problems, you can't just leave it in the form that we found first time.
I'm going to answer that question this way. It depends on how they have it on the GK. If they have it in prime factorization form, sure. Because all you're going to be doing is answering A, B, C, or D. Mr. Moyes, you want to comment on that, or?
Oh, you had it right. They're always going to put A, B, C, or D. It's only, there's no fill in the blanks.
Yeah.
So it's straight up A, B, C, multiple choice.
If they have it on prime factorization, good.
That's what I was gonna ask. There won't be a case where you can both of those years. You have to pick.
No,
I don't think so.
it will be one or the other. Right?
So I went through the examples for Just the record. But the answer is 18. All right. What is the greatest common factor of 16, 28, and 36?
Now that's marked easy. I don't think I would have marked that easy. I would have marked it maybe moderate, but
We're gonna get that for me. The person I have right now is Ms. Jones. What's the answer?
oh, she's being tricky. We're being recorded, right?
We are, you're fine.
All right, now, ladies and gentlemen, I can do all this mess. Yeah, I can do the factor tree, and I can get it right. But we have on our, Mrs. Boyce and I have on our test teacher taking test taking teacher heads right now. Okay. So it seems to me to see, let's just, it's not cheating, it's using your brains. Let's start with the big number. Will 16 go into all three of those? No, forget it. Will 8 go into all three of those? No, forget it. Will 4 go into all three of those? Yes, you have your answer. Now, if you just love drawing factor trees, fine. But if you just want down and dirty, we want you to pass the exam. So, check each of the answers, see if they work. Right, least common multiple, exactly the opposite. We did the greatest common factor. What is the largest number that will go into 2 numbers or 3 numbers? Now, the least common multiple, these are where you get your common denominator. What is the smallest number that they will go into at the same time? Exactly that. We want the least common multiple of 144 and 300. Now, if you have these big numbers, you might need to, where's the head of the ABCD?
She did not.
We'll go through these, we have time.
I have.
All right, so when you get the prime factorization,
Ms. Stubbs, we're gonna go with you. Oh, that's right. Ms. Thomas. It's okay, we need help.
12.
144, 12 times 12. She's not even using a calculator.
Using my ears.
Oh, okay.
6, 2, or 2 and 6, whatever. Okay. Yeah. 3 and 2.
That's sort of slanted, but can you still read it? We have, how many twos we have at the end? 1, 2, 3. We got 4 twos at the end. Right? So we have 4 powers of 2 times
3 to the second.
Okay. Oh, good. So now we got the prime factorization of 144. We didn't pass, but that's fine. 300. That was easy. Nobody's using a calculator. What does that tell me? Tells me you know these numbers.
5 and 2. 5 and 6. And then 6 is 2 and 2. And then 2 squared.
times 30. 5 squared.
Okay, so that's gonna give us 4, 12, 25. That appears to be correct. All right. So now, for the least common multiple, remember, for the greatest common divisor, we had how many can we extract out without going over? For the least common multiple, you've got to be covered with each one of these. You just, my secret word for the least common multiple is cover yourself. So, what is, I've got 4 powers of 2 there and 2 powers of 2 there. So I've got to have the largest number of 2s for the greatest common multiple. Excuse me, the least common multiple. So I've got to cover myself with 4 powers of 2 in this case. 3s, I've got to have everything covered. There's 3 powers of 2 and 2 powers of 3 and 1 power of 3. So how many powers of 3 am I going to have to use to cover myself? 2 powers of 3. I've got to have 2 powers of 5. And that will cover the 2 powers of 5. Wait, did I get it wrong? No, that doesn't look right. Oh, I got it right. Yes, did I do something wrong?
No, I don't know. Just asking. So what about the other 3 in that start?
It's covered. 2 powers of 3 is going to cover the 1 power. 4 powers of 2 is going to cover the 2 powers of 2. We want the least common multiple. So, as long as you're covered for these, you don't have to worry about that 3 or the other 2 powers of 2. Yes, sir.
I'm kind of confused with that.
I don't know why. Me too, but I just said okay because so for the
This is the time to ask questions. Yes.
so for the least common multiple, you're looking for the number with like that shows up the most. Well, that's what you're multiplying. That's what it looks like you're doing. You're covering it with the one that appears the most for the least common
Yes,
multiple.
that is true. That is correct.
Okay, wait. The number with the highest exponent or into the power is what it is.
Use.
Oh, okay.
Okay.
Not the least. I think that's what they're
Oh, yeah. The word least is throwing you off. Least common multiple. We still have to be covered. Okay, so now we can multiply that out. We get 16 times 9 times 25. Whatever that is, 144 times 25 is.
Oh,
30,000,
3,000.
3,000, 3,600. Okay, let's see. Clear your calculators. Punch in 3,600. Well, 144 divided into 3,600 a whole number of times. Well, 300 divided into 3,600 a whole number of times. Yes. So that's the smallest number. The smallest number that they'll both go into at the same time. That's your least common denominator. Least common multiple.
So what is the 36?
If we did it right.
So let's look at it. 144. That's it.
Okay? Good. Now, do we have an ABCD example?
Nope.
No. Okay, next topic.
That is it.
That's all the topics.
That's all the topics.
We have to pull up another, I had to pull up a whole new PowerPoint. It's finished.
So you actually did do very well today, but there are some things that we did not do that will be on the GK. So I want you to review. I have students here who will tell you that there's a whole lot of stuff that you need to go back into. And I just did a quick Google search. We did number 6, we did multiplying and dividing fractions. We did adding and subtracting fractions. We didn't do ratios. That's on the test. Comparing decimals, adding mixed numbers. We did that already too. Proportional and ratio, you need to know that. Sales tax, that's on the test. Sales tax,
I can do that. I can do that now.
show it to us with that. Show it to us.
I was supposed to go back and do some of the division of fractions, but sales tax. All right.
Quick question, what's your question?
You said Tuesday that you was gonna bring us like the cheat sheet. You printed out, you didn't bring it.
You're right, Eddie. They're upstairs in my office. I can give them to this boy and he can distribute them out.
What grades of math are questions?
What do you mean? You will level?
I understand that question. It's considered to be 8th grade.
That's where it's not saying.
It's all considered to be 8th grade. Not every day. Now, if you're taking the subject area, that's much harder.
I was doing my pre-test subject area. I was doing some hard stuff.
All right, and math? All right, the math ed people, math ed, you're going to have to go through implicit differentiation. You're going to have to do a definite integral, so you're going to have to integrate.
But you're not going to get that
That's
until you
not-
have a mathematics class. So you don't have to worry about that math component until you take her class, because her class literally prepares you for that test. You haven't had her yet. You haven't had her.
Speak to me, if you're in math ed, speak to me after class about the 612.
No. The math work for the GK, the information that you're getting for 240 tutoring will prepare you for the test. You should be fine. Okay,
All right.
yes, let's do taxes.
You are going into Burlington, not Burlington code anymore. You go into Burlington and you buy what are you going to buy at Burlington? So this jacket costs $60 and 35 cents. I just made that up. Now, in the state of Florida, your sales tax is 6%. Young County adds another percent. So Leon County is 7%. So if you're in Leon, if you're in Miami-Dade or Broward, who has all the money, right, then it's probably 6% or 6.5%. But in Leon County, we have a 7% sales tax. So you go into Kohl's and buy this jacket or whatever store you're in. It costs $60.35. Are you going to be able to pay $60.35 and walk out with it? No. You'll have to pay the tax. Unless you're in New Hampshire and they don't have any sales tax. So I really don't know how they run this well. So now, for the 7%, we can't really multiply by percent. So this is one of the things we were looking at the other day, but did not go in any detail. This is going to have to be changed to a decimal fraction. 7%, doing it quickly, without going through all the math. 7% in a decimal fraction is going to be what? 0.07.
So it's $4.
Okay, so she's multiplied. We're going to multiply our sales tax times the price of the jacket. And what did you say it was? Well, give me the whole thing.
Oh, the whole thing. It was 4.2245.
2245. Okay, so now you multiply this out, multiply it times the sales tax. So we get $4.2245, 10 thousandths of a dollar. We don't have any 10 thousandths of a dollar. We only go to hundredths of a dollar. So it's going to be the pennies. Now, are they going to charge you $4.22? Are they going to charge you $4.23? They're probably going to charge you the $4.23. Yeah, as much money as they can out of. I'm not going to round it in this case. For sales tax, in most cases, you will not round it. Let me give you a caveat for that in just a minute. So we're going to take the $4.23 and add it to the $60.35. And that's you're going to have to pay Burlington $64.58. Now, let's address the problem of the rounding or the conjunction. It's a matter of look at the ABCDs. In real life, they're going to charge you the extra. On the DK, they may round it, so you'll have to be careful. I don't think they're not going to put $64.57 and $64.58. They won't do that. It will be clear which one they're going to do for you.
We should just always do 6.
No, you should figure out where are you in the state.
No.
They're going to tell you use 6% or use 4.5%. By the way, if they said, what is if you have a 4.5% sales tax? How are you going to handle that? All right, so it's 4.5%, but 4.5%, remember we're going to have to move the decimal over 2 places. So you're going to have to multiply by 0.045 in that case.
So depending on the state, they may have already one state, they may be different. But the GK is going to give you, they'll tell you, and you need to insert it. So this is just one. There's some other stuff that you need to know. Again, this boot camp was giving you some of the things that we know you're going to see on the basic cases. But there's some other things like, I was just going to tell you, when we did these common denominators, we did geometry. No, we did do geometry. There's some geometry and measurements on there. There's also interest. Order of operation is on the test. order of operations is on the test. We went over that, on Tuesday.
Please excuse my ignorance, Sally.
That's, the other one that many students have shared with me is mean, medium, and low. I know the average, I like an average. Mean to see, and I go to the west, to the FBLA website, it's gonna tell you all the things that are on the test. Okay, this is wrong.
If we have time, I think we should go over like, I don't know what it's called, like, if there's a going to sit on something that they just say.
This helps.
Yeah, some people think it's I'm just looking. Yeah, so I was like, since there's like, this is kind of same thing, it's called like, we should come back when they do something.
Yeah, Tom. I'm gonna stop in 5 minutes because Mr. Moyes always likes to have his right. So let's see. That's okay. What store are you going to?
We're going to H&M.
Okay, you go to H&M. What are you going to buy? What is its normal price?
It's normal price is like $20.
All right, $20 is the normal price. All right. Now, they say they're having a sale, and you know that's always a big. They're not really having a sale, but they say they're having a sale. What's your discount?
It's gonna be like
30% off.
30% off. So now, what did we do to the sales tax in terms of the regular price? We multiplied and then added it. For the discount, we're going to multiply it. So then we're going to subtract it. So let's change that. That's going to be 0.30 or 0.3. Your calculator's not going to show the zero. So we're going to multiply the 20 times 0.30, and that's going to give us $6 if I did that right. You can check it out on the calculator. So now, this $6, if it's a discount, you're going to subtract it from your normal price. So your shirt is going to cost you $14 after the discount. Are you going to walk out of H&M? You've got it as a tax. Then you're going to have to add the tax, which is times, another decimal out here. And then add it. Because the state of Florida is not going to let you walk out with just the price.
Will they do that? Will they have discounts and then sales tax on top of it?
Yes. Except on the tax-free days, and I don't know how that works.
Just don't add the tax.
Well, now, before, about 2 or 3 weekends before school starts, they have a tax-free day on just about everything.
So like, the discount price, that sales tax also in the question?
It depends on what the question is. If it says the discount is 20% and the sales tax is 4.5%, yeah, then you've got about 3 different problems.
Now, for the boot camp, the order that Dr. Hall and this, of course, Dr. Fitzmanis to put this in is, I thought was really important because again, they're breaking it down by topic. So when you're studying, study in that manner. Break it down by topic so that you know what? I know my ratios. I know my multiplication. I know how to subtract. I know how to add. When you have that down, you're figuring out what you don't know. Does that make sense? So I have a problems with, let's go back to sales tax. During your time, during your study time, you need to spend more time on sales tax. Does that make sense? So again, that same process you can use for the ELS. Does that make sense to you guys? Yes or no? They're gonna tell you what's on the test. All you need to do is go down and figure out what you don't know. And then from there, study the things that you don't know. Review the things you know, but put more effort in the things you don't know.
Was that the pretest report just to see like the
Correct. The pre-test is gonna tell me what I know. And then from there, okay, I'm not where I need to be. That means I need to start studying and reviewing. And you see on 240 tutoring, it doesn't allow you to move forward until you pass that component. Until you master that area, then so okay, now you can move on. But as you guys continue to study and prepare, set it up so that you know, okay, I know these components, I can move on to the next section. They're already telling you what's on there. Once you know you've mastered it, you move on to the next.
Also, ladies and gentlemen, if I'm in my office, I don't mind you coming to me and we can go over stuff. I will do that on an individual or even a group basis, no matter what, if I'm there and available.